over quadratics that you may or may not have had in Algebra 1. We're doing day 4 talking about quadratics in standard form. If you look over here on the right in this box, it talks about this is what we call the parent function. This is in standard form. We have ax squared plus bx plus c. This is kind of the normal way we want to see things. X squared, then the x, then the number without an x. This is the formula for axis of symmetry. That's an important one to know. It's not on the reference sheet. In the picture you can see the axis of symmetry. You remember the word symmetry means symmetrical. This is the line that goes down the middle of a parabola, which is the shape, that it gives the mirror image on both sides. It's symmetrical on both sides. This is called the axis of symmetry. Given an equation, this is how you find the axis of symmetry. It's negative b, or the opposite of b, divided by 2a. In this picture of the parabola, again, I'll just write that word here, parabola. That is the graph that's formed by the quadratic equation. These are called your x-intercepts, because this is your x-axis. Then we have our y-intercept, because this is the y-axis. This point right here is called the vertex. To find the vertex, we have details over here. You first find the axis of symmetry. You'll notice that's x equals, that gives us the x value, and then you plug that value in for x into the equation and solve for y. That will give you this ordered pair of x comma y to show you what the vertex is, how to graph it. So let's start down here. This is already in what we call standard form. I'm going to say a equals 1, b equals -6, and c equals 1. Okay? So we're going to find the axis of symmetry first. The axis of symmetry is the x equals -b divided by 2a. So x equals -6 is going to change this to a +6 divided by 2 times 1. Well, 2 times 1 is 2, so 6 divided by 2 is 3. To find the vertex, now you plug 3 in where you see x, because this is x equals 3. So if I plug that in, we would have 3 squared minus 6 times 3 plus 1. So we have 3 squared minus 6 times 3 plus 1. That is -8. So that was y equals that. So our vertex is the ordered pair 3, -8. Once you have your axis of symmetry and vertex, once I have my vertex, I go ahead and draw like an XY chart coordinate plane like this one is. -8 is pretty low though, so I think I'm going to draw mine actually a little bit higher than maybe normal. Doesn't always have to be in the center, so let's say in this case I want to graph the point 3, -8. 1, 2, 3. Okay, this is my vertex. When you make a table of values, we can use our graphing calculator to find that table, but if you're at home and don't have a graphing calculator, the point 3, -8 goes in the middle of your table. And you want to do 2 points on each side. Now it might work out that we can't always graph those other points, 2 points on each side. So like for instance, if 3 is in the middle, we want to do 1 and 2, that would be below it, and we want to do 4 and 5, because that would be above it. Again, if you don't have a graphing calculator at home, we're just going to plug in these numbers for x and find the point that we're going to plot. So if you put a 1 in this equation, like I did here, we would have 1 squared minus 6 times 1 plus 1. I get the answer of -4. Then I would plug 2 into the equation where the x is. That would be 2 squared minus 6 times 2 plus 1. -1. Then we have 4 squared minus 6 times 4 plus 1. -7, the Same thing with 5. 5 squared minus 6 times 5 plus 1 is negative 4. Here's the deal. If you are filling out a table and it doesn't look like this, it doesn't go down and back up or up and back down. Like if it doesn't look like this is in the middle, it probably means we found something in the axis of symmetry wrong or the vertex wrong. So we're going to graph these points. 1, negative 4, 2, negative 7, 3, negative 8, 4, negative 7, 5, negative 4. And it's going to make, we're going to sketch this. It's not perfect, not exact, but we're going to sketch the idea of what this parabola is going to look like. So I always use a pencil because it's not exact, but that's a good idea what that quadratic graph would look like. If you have a graphing calculator at home or the graphing calculator app on your iPad, you go to your y equals button here, and you're going to type this in. This is your x button. I don't know if you can see that. X is right here, so you're going to hit x squared, and then minus 6x plus 1. And to get to this table of values we're talking about, you hit the blue button in second, and then the word table over here. And you can look here, you'll notice these are going down and then back up, so this point here is the vertex. It is, in this case, the lowest point in this graph. So you can get your table by plugging the numbers in for x, or you can get your table by using your graphing calculator. The main thing is, where do I start the table at? You start the table at that axis of symmetry. That has to go in the middle of your table, because if this is symmetrical, that means at the point x equals 3, this is 1, 2, 3, x equals 3, that's where your line of symmetry is. That's where it's going to fold in half. Alright, let's try this one. This one looks a little different. It's still standard form technically. So the a value is 1/3. Your b value is 0, and your c value is 0. So if you look at that, and you plug those numbers in, negative b, well that's 0 divided by 2a, so 0 divided by 2 times 1/3. Well, 0 divided by anything is going to be 0. So our axis of symmetry for this one, x equals 0, is going to be like our middle line. Guess what? If you plug 0 in, y equals 1/3 times 0 squared, well, that's still going to be 0. So our vertex for this one is at the point 0, 0. So 0, 0 for this one is going to go in the middle of our table. So I need to do the numbers like negative 1, negative 2, 1, and 2. Again, you always want to put the vertex in the middle. And now we just plug in our numbers. So if I did 1/3 times negative 1 squared, well, negative 1 squared is 1 times 1/3 is 1/3. This one's not really a nice one to do because, like, if you take negative 2 squared, well, that's 4 times 1/3. That would be 4/3. Well, that's like 1 1/3. So if I wanted to do this and maybe get a better number, I would probably plug in a 3, because finding a third of something is probably going to be divisible by 3. So, like, if you did 3 squared is 9, and 9 times 1/3 is 3. So sometimes when you have fractions, it's maybe easier to do numbers that are divisible by that. So, but we can graph the point 0, 0. You want to graph negative 1 1/3. That's really little. And then negative 2 is 1 1/3. The idea behind this one is, you'll notice this one is a lot wider than the last one. So we're going to get to the point, if you can tell how things change. like this has a width of 1. So the first point, the A value kind of tells me it's 1, so I can go like up 1 and over 1. This one, to get to the next point, the A value is like 1/3. So really, you could go up 1. The 1/3 doesn't work quite as well as the other ones. Basically, because like if you look at this at 3, we were at 3. 1, 2, 3. So I drew mine a little bit wide, but the idea is to see that if it's a fraction, your information is going to be much wider than if it is just a 1. The parent function has an x² value of 1. Alright, we look at the next section. We are analyzing graphs. Finding a vertex in a picture is kind of this point here. So based on the picture at the top of your page, you can label your pictures with what you have. That would be a vertex. These would be what we call x-intercepts. This would be what I'd call a y-intercept. This line here, where it cuts the picture in half, is called the axis of symmetry. So let's see if we can put some of that over here in our table. So your vertex in this picture would be 4, 2. Your zeros are also known as your x-intercepts. So that would be the point 2, 0 and 6, 0. Your maximum or minimum in this picture, I would say this parabola has the vertex is its maximum point. The y-intercept in the picture is at -6, so we'll say it's at 0, -6. Line of symmetry is that dashed line. I said that's halfway. It looks like it would be right here at 4. So we're going to say x equals 4 is the line of symmetry. Increasing. Increasing, when you read a graph, we read a graph from left to right. Assuming this parabola is going to continue forever, we'll assume that there's arrows on the end of this. We would say it is increasing from -infinity to what point does it stop increasing? It stops at 4. 4 is like where it's going to start going back down. So we look at your x values for this. So I'm going to say at the point 4, and I'm going to put a bracket here because that's where it stops. This is called interval notation. I don't know if you guys worked on that. Another way they write that is it's sometimes, well, we can write that on domain, but so if it's an arrow on the negative side, it's going down. That's -infinity to 4, and oh, I wrote that on the wrong one. Decreasing from -infinity to 4. 4 means it's actually a stopping point. They use parentheses when it's like an arrow on the end of things or open circles. If it has actual points there, then that means it's a closed bracket. So increasing, my goodness. Increasing is where it's going up. It's going up from -infinity to 4. I did have that right. It's decreasing from 4 to infinity. Read a graph from left to right, Ms. Campbell. So when you're reading a graph, it would say that as far as increasing means where is the graph going up. If you look at this graph from here to here, that would be what we call increasing. So the other side of that, where is it going down, this would be decreasing. But to find the values of that, you look at the x values. So it stopped increasing when it got to 4, and it started decreasing when it got to 4. Alright, domain is your x values. Range is your y values. With domain, from left to right, it's going to keep going from left to right. So we say the domain goes from negative infinity to infinity. So notice I use parentheses because arrows means it continues forever. Range is what your y values are. I would say it would go from negative infinity up to right here. So it stops at 2. So I'll say it's negative infinity to 2. And because it stops at the point 2, I'm going to put a bracket on that one. If it goes on forever, we use parentheses. If it has a stopping point, that's when you use a bracket symbol. Alright, this next one we're going to do, we're going to not only graph it, and then we're going to analyze our graph. So to start by graphing it, you need to find the axis of symmetry, and that formula was x equals negative b divided by 2a. So in this case, this is our a equals 1, b equals negative 6, c equals 8. Okay, so negative 6, or opposite of negative 6 is positive 6 divided by 2 times 1. That equals 3. So I'm going to make a table of values. And I want to put 3 in the middle. So I'll do 1 and 2. 3 is going to be my vertex, 4 and 5. So let's plug these numbers in. Let's see, 1 squared minus 6 times 1 plus 8. That equals 3. Plug in a 2. 2 squared minus 6 times 2 plus 8. 0. 3 squared minus 6 times 3 plus 8. Negative 1. All I'm doing is putting these numbers in for the x. Okay, look at that. 4 squared minus 6 times 4 plus 8. 0. Last one, 5 squared minus 6 times 5 plus 8 is 3. So I changed for the x's, I put those numbers in, these are the answers I got. So your vertex for this one is the point 3, negative 1. So I'll go over here and graph these ordered pairs. 1, 3, 2, 0, 3, negative 1. And general shape of our parabola. The zeros are where does it cross the x-axis. This one, these are our x-axis here. So its x-intercepts are at 2, 0, and 4, 0. Okay, this one has a minimum point. Okay, the y-intercept, well, I didn't find that yet. So, in order to find the y-intercept, we actually need to plug in 0. The y-intercept is when is this going to hit 0. So if to do that, I'm going to write it down here. If you plug in 0, you would get 0 squared minus 6 times 0 plus 8. So that comes out to 8. So 0, 8 is our y-intercept. I just didn't graph that because I didn't know if it'd go that high. But so find y-intercept. If it's not in the picture, plug in x equals 0 to find the y-intercept. Because an ordered pair for a y-intercept is 0, a number, so you just got to plug in 0. The axis of symmetry is where does it cut the picture in half. So this would be our axis of symmetry, and that is at 3, which we found that right here. This was our axis of symmetry. We already did that work. So that was x equals 3. Increasing, where is it going up from? I would say from 3, it starts going up. So I'll say from 3 to infinity. It's going to keep going up. Where is it decreasing means where is it coming down? I would say from negative infinity to 3. Again, anytime it has a stopping point, like a number 3, that's where you put a bracket. Anywhere there's an arrow, that would be where you put a parenthesis, and use like infinity or negative infinity. Alright, so how do they ask this on the EOC? Not only will they ask you analyzing questions like increase, decrease, domain, range, things like that, they have you compare two functions. In a table, this is our function 1, and here is our function 2. So sometimes I feel like the easiest way to do this is just to sketch a graph. So I'm going to sketch a graph right here. Again, this is not like a very fancy graph, but I'm going to graph the point 1, 5, 2, 2, 3, 1, 4, 2, 5, 5. Okay, so I'm going to say this one is function 1. I'll just put number 1 by that. Okay, so graph number 2, we would do the B turn A is 1, B is 0, C is negative 1. So axis of symmetry would be 0 divided by 2, which is 0. So this one has vertex 0, comma 0 minus 1 is negative 1. Okay, so this one has a vertex at 0, negative 1. And then, like, if you want to do an XYT chart, you could probably learn enough information there, but we would do each side of that. So if I plug in, like, negative 2 squared is 4, minus 1 is 3. Negative 1 squared is 1. Minus 1 is 0. 1 squared, that's 0. That's 3. So let's graph those points in. Negative 2. Negative 1, 0. Okay, so this is number 2. And on the EOC, you get graph paper, like scratch paper, to draw these on, so you don't have to make up like your own graph. So looking at these, function 1 has a larger minimum than function 2. Well, that's true. See, number 1's minimum is here. This is its minimum point, and this is its minimum point. So yes, function 1 has a larger minimum than function 2. Function 2 has a larger minimum. Function 1, nope. Both functions have the same minimum. Nope. Neither function has a maximum. They both have minimums. Well, that's true. Neither function has a minimum. Well, they both have minimums. Function 1 has a minimum, and function 2 has a max. Well, that's not true. So on a lot of these, it's like select all that apply, and a lot of people will see that first one and just quit and not even look for the next one. So neither function had a maximum. They both had minimum points in this. This one's a little bit better because they like at least graph one of them for you. So if you were going to graph this, this is your A, B, and C. So your axis of symmetry would be negative 4 divided by 2 times 4. Negative 1/2. Great. We love fractions. So we're going to put negative 1/2 as our vertex, and then let's do like 0 and negative 1, just to kind of do something on each side that might be a little easier. Or we could do negative 2 and 1. Let's try it. So we're going to plug those numbers into this problem. It only really talks about minimums here. So let's just find the vertex and see how that compares to this vertex. Okay? So 4 times negative 1/2 squared plus 4 times negative 0.5 or 1/2 minus 3 equals negative 4. So negative 1/2, negative 4, which is off my chart here, will we'll say that's where it is. And if you plug in 0, you're just going to be at -3. This is kind of gives you an idea what it's going to look like. Alright, so this is your f function, that's your g function. F has a greater minimum than g. Yes, that is definitely lower than that one. G has a greater minimum than F. Nope, that's higher. F and G have the same minimum. So they're just seeing, 1, can you graph it? 2, do you realize this is a minimum point and this is a minimum point? And how do they compare? Okay, those are the way evaluate EOC questions look like. Okay, we're going to compare these last ones, and then we're going to take a break before we get into solving quadratics. How many roots do the following functions have in common? Roots are zeros. Zeros are where it hits the x-axis. So, this one is at 2, 5. The root of the other one gets into factoring, or we can graph it on our graphing calculator. X squared minus 4x minus 5. Then I hit graph. Okay, this one has one at -1 and -1 and 5. So here's the other one, -1 and 5. Okay, I did that by the graphing calculator. I'm going to show you how to find that in just a second. So roots are also known as x-intercepts or zeros. So this one, they have this one in common. F and G share the same roots. Not totally. F and G share one root in common, but each have another root that is not shared. That is true. F and G have no roots in common. Nope, they shared the one that was 5. Alright, the next video is going to show you how to factor that, and that will also be another way to solve, or using the quadratic formula.